All right, hello, this is Mr. Wallace again with another review for Algebra 1. This is Lesson 2 Practice on page 7. We are doing numbers 6 and 7. All right, so number 6 says, given the following equations, determine if each represents a linear or exponential function, then identify the y-intercept and determine if the relation is increasing or decreasing. All right, so a linear relation is in slope-intercept form, which is y equals mx plus b. And everything in exponential form is y equals a and then bx. B is my growth rate, and then that little x is my exponent. So that first one is in slope-intercept form. I have y equals negative 4x plus 16. That, since it's in slope-intercept form, is linear. My y-intercept is that last number, so my b value always in slope-intercept form, so that's going to be 16. And since I do have a negative slope, so negative 4, that means it is a decrease. All right, so letter B, it's a little changed between exponential equations and slope-intercept form. That first number this time in exponential form is my y-intercept. So 12 is going to be my y-intercept in this case. Because I do have something being multiplied, I have my initial value and it's being multiplied by a growth rate. That means it's exponential. It's different than slope-intercept form to where we have a constant. Here we have multiplication. And because this b value is greater than 1, 1.65 is higher than 1, it is increasing. Okay, number 7, we have 8 equations, but it's going to go pretty fast as long as we know the pattern that's going on. Anytime that we have exponential, remember that initial value or that y-intercept is always that first number. So that first equation is 7,500. And I'm just going to go down each column there instead of the rows. So down each column. Here, there's nothing there, but since there's nothing there, it's always assumed 1. So that would be 1 is my y-intercept. In equation number 3, it's 900 is my y-intercept. Next one, 24,000. Next one, 750. Next one, wow, that's a big number, 250,000. Imagine graphing that. Next one is 11,275, and then the last equation for number 8 is 673. So these are just the initial values, and the point of this is just to show you guys the pattern that's happening, that first number. All right, growth or decay, I'm just going to put G for growth or D for decay, and that's simple. If that growth rate, that number in parentheses is higher than 1, it's always growth. So here we have 1, that's an adding of a 0.03, so that's going to be growth. Less than 1, decay. More than 1, growth. There's a minus right there, so that means it's going to be less than 1, so that's decay. That's above 1 for growth, below 1 for decay, above 1 for growth, and below 1 for decay. Look at that. Nice little 1, 2, 1, 2 right there. All right, last, when I teach this is possibly the most confusing part. If you want to think of percent change as difference from 100%. So think of percent change from either going above 100% or below 100%. And in our packets, we are working on our 1 plus our percentage, that's for increase, or 1 minus our percentage, and that's our decrease. So try to think of that. So from 1, I'm going to 0.03. Well, 0.03 as a percent is 3%. So I'm going up 3%. Here from 1, I'm going to 0.85, so I'm actually going down 0.15, which is 15%. Here I have 1.27. That 0.27 is an additional 27%, because remember, converting from decimals to percent, you just move the decimal place over 2 times to the right. Here it tells us right here we're going down because of the minus sign, and that 0.08 is down 8%. Here it's above 1. That 0.15 is 15% again, because that's going above 1. This next one here, I'm going from 1 down to 0.65. So my percent change isn't 65%, it's from 35%. And notice the pattern here, we have growth are always plus, decay are always minus. So here we have 1.1, so I'm going up 0.1, which is 10%. And very last one, from 1, I'm going to 0.8. So it's basically 1 minus 0.8 is goes back to our 1 plus or 1 minus. Well, 1 minus 0.8 is 0.2, which as a percentage is 20%. So we're going down 20%. I know I went through that pretty fast, but you can re-watch this section a few times and pause it as necessary. So, all right, thank you so much.